If you like my dad's videos, please subscribe to QA Insights channel.
In this episode 5 of Performance Engineering series, today we are going to talk about garbage collection. In the last video, we have discussed about JVM memory and also we have touched a little bit about garbage collection. Today we are going to deep dive into garbage collection concepts. Just to recap, garbage collection is one of the core features of JVM, which will help you to clear up the objects which are no more required. So it is automatic. Developers can concentrate on their code. Rest everything will be taken care by the JVM. So it cleans up all the unreferenced objects whenever threshold reaches. Based on the settings or based on the JVM arguments, it will decide whether to clean up or not. So this process, it's a kind of very expensive, meaning your application will not be functional. It will not take or process your requests because it will be concentrated to clean up the mess. Garbage collection can be classified into different types. It depends on the region where the garbage collection takes place. If it happens in the younger generation, then we can call it as minor GC. If it happens in the older generation, we can call it as a major GC. And if it happens across younger plus older, then we can call it as a full GC. But in some context, full GC is also known as major GC. So it depends in which JVM you have installed and what kind of GC is happening. You can visualize this in the tools like Visual VM so that you can understand what type of GC has happened. Whenever GC happens, your application will not process any requests because your JVM will be busy in clearing up your unreferenced objects. So definitely there will be an increase in the latency. Even in the minor GC also, you will see the latency increase, but it is negligible. But major GC, we can easily figure it out because the major GC duration will be high when compared to minor GC. Now let us talk about how GC works. So GC follows very simple high-level algorithm. First phase is marking. During the marking phase, it will just mark all the unreferenced objects starting from the root. In the next phase, it will start sweeping up all the unreferenced objects. So whichever objects is not referencing in the stack, then those objects will be removed during the sweeping phase. And then it will compact the memory just to make sure JVM works efficiently. Assume that we have a large heap, and whenever you employ this particular mark and sweep, what will happen is it will take more time because the heap area is very large and marking and sweeping is very tough, and also it will take more time. Assume that you are living in a house and suddenly it becomes mess. If the house is larger, then you will take more time to clean up the mess. But if you go room by room, or if the big house is divided into multiple zones, then you can plan and sweep the mess accordingly. So that's why we have the young and older generation. The purpose of younger generation is all the objects, the newly created objects or shortly lived objects will be there in the younger generation. And if the object is living for a long time, so there is a reference to the stack for a very long time, then those objects will be removed gradually to the older generation. The recent JD case, it is very smart enough to execute when the garbage collection should happen. It will employ multiple algorithms just to make sure your application runs smoothly, and it is smart enough to schedule the garbage collection at the right time. So that is why minor GC will always have the shortly lived objects. The sweeping up is very easy. It takes very less time. But major GC, it's a long lived objects. It will take more time to sweep. Now let us talk about types of collectors. In Java or JVM, there are multiple collectors. Starting from the older version, we have a serial collector, which executes your GC using the one thread. Then we have parallel collector. Using multiple threads, garbage collection will be taking place. And then we got concurrent mark and sweep. So concurrently it will mark and sweep, and it is one of the commonly used collector. So if you use this CMS, the garbage collection pass time will be very shorter. And we have a garbage first G1 GC, garbage first garbage collection. It is one of the commonly used collector again. So this also will have the very less time, and you can achieve the high probability of the shorter cycles. For example, if you take JMeter or a NeoLoad, it employs the G1 GC by default. So you can set the algorithm, whichever algorithm you would like to keep, you can configure in the bat file. And then we have a Z garbage collector. So you can turn this on using the experimental options. So it is a scalable, a low latency garbage collector. So everything will be done within the 10 milliseconds. And then we have Shenandoah. Shenandoah also, it's a low pass garbage collector for the low latency applications, which will reduce the garbage collection heavily. So the concept of Shenandoah is like it employs the worker queue concept. And at last we have the Epsilon. So Epsilon is very special type. So whatever we have seen before, it does the garbage collection process, but Epsilon will not do any garbage collection. It is also known as do nothing. So whatever you allocate the heap, once it is used, it will shut down your application. So it will not do any garbage collection. So you might ask why we need this kind of collector. So whenever you know, okay, this is the application I'm going to use, which will be using only this much of heap memory, and it will not exceed the particular threshold, then if you're confident, then you can go with the Epsilon. And also it is very helpful for testing purpose. So if you have a heap memory allocated, say 1 GB, and make sure the 1 GB is reached, and then your application is running fine within the 1 GB, then you can adopt this Epsilon algorithm. Now let us see a quick demo how you can employ this particular GC algorithm in JMeter and see how it behaves. So first thing what we are going to do is we are going to leverage a utility called jcmd to identify what are the flags we have set for the JMeter. So right now I have JMeter which is up and running here, and let me just arrange this window. And first thing, we have to identify the process ID of JMeter. To get the process ID, you can use the command line, or you can go to the task manager and you can get it. But you can also use jcmd-l and hit enter. So this will list out the process ID. So in the left side, you will get the process ID. On the right side, the program name. So here you can see the process ID is 8828 and the name is apache jmeter.jar. So now you can use this 8828. So just type the process ID and enter VM with the caps on dot flags in small letter and hit enter. So now this will give you the JVM arguments of JMeter. So whenever you launch JMeter, these are the arguments which will be passed by your JVM. So here if you see the arguments such as use G1 GC, and also here we have the heap dump on out of memory error. So these are some of the arguments we need. So by default, JMeter uses G1 GC. And also whenever some out of memory exception happens, then it will automatically take the heap dump. So this is the argument for that. So whenever you use a plus, which means you are enabling the particular flag, and whenever you use a minus, then you are disabling the particular flag. Okay, now let me open Visual VM. And here also you can see the process ID is 8828. And I'm going to launch this. And here you can also see about the JVM arguments. So right now I have set the maximum heap space is around 128 MB. So this is intentional. I am not setting 1 GB. Just to demonstrate, I am setting this value to very lower. Now what I'm going to do is I'm going to launch JMeter, and inside JMeter I have one request. So this request is hitting the port 8080. So I have something running in this particular port. So now let me right click and validate. So now in the request you can see the response body and response headers. So I'm running some Jetty application. Now in the thread group, I have mentioned just one thread, and ramp up is 1 second. And let me go back to Visual VM. Now just go to the monitor tab, and here you can see your heap and metaspace, and also classes, threads, and CPU. So I can just close the CPU, and I can close the classes. We don't need as of now. And at the top right, you can see perform GC. So this particular button will manually initiate the garbage collection process. But don't do that. It is not advisable. Just for the demonstration purpose only, I'm just showing you. But whenever you are running the application in the production, don't initiate the garbage collection manually unless it is for the testing purpose. So JVM should take care of your garbage collection process. Now let us go back to Visual GC, and as you know, in yesterday's class, we have seen about the spaces, metaspace, old, Eden, and we have the survivor space S0, S1. And right now your application is running smoothly because we are not doing anything in JMeter. Now what I'm going to do is I'm going to increase this thread, say 200, or let us go with 100, and let us kick off this run. But this is not the way you should execute. Just for the demonstration purpose, I am showing you. In a real project, you should give some ramp up period, and you should take care of your think time and other stuffs, and also you should run in the CLI mode. Just for the demonstration purpose, I'm just using the UI. Now I'm going to start running this particular thread group, and right now it's running fine. As you see, everything is fine. And now let us switch to Visual GC, and here if you see, the older generation suddenly bumped up, and also the newly objects is getting created in the Eden space, as you see here. So the object is getting created here, and also it is getting cleaned up, and the matured objects will be moved to old. And also once the old is reached some threshold, JVM will decide whether garbage collection should happen or not. So according to that, it will just clean up the unused objects. So here you can see how many times the GC is happening. So for example, if you see the older generation, there are 3 collections. So 3 collections means 3 times old generation has been cleaned up. And if you see the Eden space, every second, I guess, some minor GC is happening. So it's around 600 now. 600 collections has been happened in the Eden space. And also if you go back to your monitor, and here you can see this is our startup time, ideal time of JMeter. Once the application is started, it reached around 100 MB, and it is trending around 120, between 100 to 105, something like that. And it is just trending because our application is working fine and we are not facing any issue. So now what I'm going to do is I'm going to stop this run. Once I click on stop, the allocated memory should come down. So now if we go to Visual GC, you don't see much of garbage collection because we are not doing anything crazy. So that's why the number of collections is not increasing as before. So now if I wait for say a couple more minutes, eventually the heap size, used heap size will reduce. Now what will happen? What we are going to do is we are going to increase this number to say 200. Now we are injecting more threads, and more objects will be created, and more GC will happen. So we are going to observe that. So now let me click on this run, and let us go to the monitor. And here, as you see, the memory has been dropped, and again it is increasing. Now if you go to Visual GC, again you will see the number of collections. It's heavily increasing. And also the older generation also, it is very busy. So it is reaching maximum around 121, 126 MB out of 128. And 14, 15 collections has started increasing. So now there is no crash because we can see it here. So that is why I opened this command prompt. So in the command prompt, we are not seeing the any exceptions. So now what we can do, let me stop this. And let us increase to say 400, and let us start the test. And let us go back to Visual GC and let us observe what's going on here. And if we go to monitor also, you can see it is trending at around 123 MB of used. But we have around 128. So this is the 128 MB, that is the heap memory we have allocated. And this setting also, it is working fine because we are not seeing any error. Now let me aggressively increase the number. Let me stop the test and let us go with say 600. And let us start executing. Now you can see older gen is bumped up at very top, and let us wait for a couple of seconds. Okay, now you see JMeter is throwing out of memory error, and it is dumping the heap to this particular the current location of the folder, which is bin folder, and the file name is java_pid8828.hprof. And if you go back to your Visual GC, as you see, nothing is happening. Only the minor GC is happening here because the application has been crashed. And if you go to monitor, you can see the heap memory has been reached the maximum threshold. So you can see here. So now, since we allocated the heap memory is very less, that's why we are getting the out of memory error. But in the ideal scenario, minimum I will allocate 1 GB. But just to showcase how the GC happens, I just reduced the number. So now let us, actually we cannot do anything. We have to close this, and also we can see a lot of errors here. So let us terminate this particular program. So we have successfully crashed our application by injecting the out of memory heap space error. Now let us see how you can change the garbage collection algorithm to something like Epsilon and see how it behaves. To change the algorithm, I am going to take again the JMeter example. So let me launch the bin folder here. And okay, so here you can see the heap dump. So in upcoming classes, we can see how you can analyze this file. And now let me open this jmeter.bat. So here, just search for xmx. So that is the maximum heap size. So here you can see this is the heap size I have set. Initial heap size is 128 EM. And maximum also 128 EM. So by default, it uses G1 GC. So we are going to override this. To override, I'm going to use this unlock experimental VM options, and we are going to use Epsilon GC. So now let me change this back to say 512 MB. I think this should crash, I believe. Now let me save this and go back to bin and let us launch. Okay, multiple garbage collector selected. Okay, somewhere we have to override. So let me close this. Let us quickly search for G1 GC. Okay, here we can pass the value, and let us delete from that older place. Okay, so in line number 162, you have to add your GC algorithm. So by default, it was G1 GC. So now let me go back to the bin folder and let us open the JMeter, and let us go back to Visual VM, and here you get the new PID. Let me open this, and in the new JMeter you can see the initial heap size is 512 and maximum also 512, and here also you can see the GC algorithm is Epsilon. Now let me open the gc.jmx, which we have used in the previous exercise, and here let me change this to say 100, and let us start our run. So before that, let me go to the monitor. So right now you can see it is using around 486 bytes, 486k bytes, and let us start the run. So now, as you see, once we have started, the application has been crashed and it closed automatically because the allocated memory has been reached. So here you can see it reached to 512 MB. So once it is reached, the Epsilon GC will not do any garbage collection. So the purpose of Epsilon is it will allocate, and then it will just do nothing, and then it will just crash the application. So this is how you change your GC algorithm, and run your experiments to observe your application behavior. So I hope this session is pretty useful. In upcoming videos, we are going to simulate different types of error, and we will see how you can leverage multiple tools to fix your performance bottlenecks. Thanks for watching. Have a good day.
If you like my dad's videos, please subscribe to QA Insights channel.